Well, hi. I hope you guys did wonderfully on your quiz today. I want you to load up the formula chart off your computer, the one that we use for our proofs and our identities, or you can re-download it again from the assignments page. And we're going to go further into this. We just took a quiz over reciprocal, Pythagorean, and quotient, and in this lesson we're going to investigate the bottom half of this formula chart, our odd-even functions, the cofunctions, and the composite arguments, which is the sum and difference formulas. So we're going to do some examples based on this. So pull that file back up, or you have a copy of it so you could get that out. So I'm going to be looking at those today. Alright, so let's take a look at what we got here. The first example I want to do, let me see here, let's do green, see how that works. First example I want to do is the sine of 36 degrees. And we're going to say, what does this equal? And of course I could ask my calculator what it equals as a decimal, but that's not the instructions. The instructions are going to say use the cofunction properties to find out what this is equal to without a calculator. So I don't want a decimal. What I want to know is, what does sine of 36 equal in terms of its cofunction? Alright, so what we're going to do is look at our formula chart, and we're going to see that the cofunction of sine is cosine, and the cofunction of cosine is sine. So they're cofunctions of each other, and the co is very similar to complement, and you can see that they have that same 90-degree angle relationship between the two. So this is what that means. That means that the sine of 36 is going to be equal to the cosine of an angle, but this angle that I write is going to be 90 minus 36. Let's look at that again. The sine of 90 minus an angle is equal to the cosine of that angle. Or if I want to know the sine of an angle, it's the cosine of 90 minus that angle. So the sine of x is cosine of 90 minus x. And on your formula chart this is in radians, but I'll just talk to you in degrees today. So this is the same thing as cosine of 90 degrees minus x. So the answer to this example is the sine of 36 degrees is equal to the cosine of 90 minus 36 degrees, which is the cosine of 54. So you see this cofunction has a complementary relationship. This angle 36 plus 54 equals 90. And you can ask your calculator this, the sine of 36 and the cosine of 54, and you'll see that it's the same value. Another example would be the sine of 20 degrees. Use the cofunction properties to find the sine of 20 degrees. Well, in terms of cosine, what angle adds to 20 to get 90? And of course that's 70 degrees. Okay, so on this chart we've got sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. So that should be rather easy for you to see. We'll still do an example though. How about the cosecant of 35 degrees? What is a cofunction property for that? And that would be the secant of 55, because 55 and 35 is 90. And then the last example is, if I have the tangent of 15 degrees as a cofunction, what would this equal? And that would be the cotangent of 75. So I hope that that's really easy for you to see. Alright, so what we're going to do next are our sum and difference properties, which is the bottom half of that page. Alright, so what we're going to do is we're going to take a look at cosine of a plus b, and we are going to see that this does not equal cosine a plus cosine b. In other words, cosine does not distribute through parentheses. I'm going to prove that for you real quick. If a is 30 degrees and if b is 90 degrees, then the cosine of 30 plus 90 does not equal the cosine of 30 plus the cosine of 90, and here's why. 30 plus 90 is 120, so this would be the cosine of 120. and 120 degree. Oh wow, I don't guess I've drawn a straight line in a while. That is really horrible. Sorry. All right. Over here is 120 degrees. Reference angle is 60, 30. Well, we just can't get away from this, can we? It's almost like I want you to learn this or something. Across from the 30, we're going to put a -1. Why is that negative? I wonder. Across from the 60 is the square root of 3. Hypotenuse is 2. Never negative on the hypotenuse. Cosine of 120 is adjacent over hypotenuse. That's -1/2. Okay, cosine of 30 degrees. I'll draw that over here. 30, 60, 90. 1 across from the 30, square root of 3 across from the 60. 2 on the hypotenuse. The cosine of this is square root of 3 over 2. And the cosine of 90 degrees ends up right here on the positive y-axis. That's going to come from our unit circle. Boy, I've drawn this picture a whole bunch. Right up here at 90 degrees, that ordered pair is 0, 1. The first number is the cosine. The second number is the sine. So the cosine of 90 degrees is 0. And you can see that this is not a true statement. Now there will be some of you that will still distribute the cosine through there because you see something outside parentheses and hey, it's the distributive property. Woohoo! Hippity hoppity. No, you will not hippity hoppity with cosine. You can't do it with sine or any trig function. So that's the first thing I want to get out of the way. Now, since it doesn't equal the distributive property, how are we supposed to evaluate cosine of a plus b? And this is where you look at your formula chart. I want to extend page. I just want to go to a new page. You're going to look at your formula chart and you're going to see that cosine of a plus b has a formula. It's the cosine a cosine b minus sine a sine b. There is your formula to find the cosine of a plus b. Yes, it's messy. Yes, it looks difficult, but at least it's correct and not silly. Alright, so what we're going to do is we're going to take a look at an example of how to use that. That's the wrong page. That is the right page. Sticking with green, it's working for me. Okay, so we're going to simplify the given expression using our sum and difference properties. I'm going to simplify the cosine of 34 degrees times the cosine of 20 degrees plus the sine of 34 degrees times the sine of 20 degrees. And I want to see what this is equal to. So what I'm going to do is I'm going to go to my formula chart and I'm going to see what this looks like. So I've got cosine of an angle plus the sine of an angle times the sine of an angle. So let's go back and look and see what happens here. Looky here, it matches the cosine of a plus b. Cosine of an angle minus the sine of an angle, sine of an angle. But wait a minute, that's a plus sign, so it's not cosine of a plus b. It's the, look over here. Cosine a cosine b plus sine a sine b is equal to the cosine of a minus b. So you just have to look and see. I keep pressing that button. That's the wrong one. You just have to look and see what would A be. A is 34 degrees and B is 20 degrees. So this simplifies into the cosine of A minus B, which is the cosine of 14 degrees. So I turn a really long expression into one single expression. Okay, let's do a proof. Yay, proof. Let's prove that the cosine of x minus pi is equal to negative cosine of x. And the way I'm going to do this is I'm going to start with one side and I'm going to use my identity chart to simplify it and see if it looks like the other side, just like we did the other proofs. Except this time I'm going to be using the formula chart, the bottom half of the formula chart. So let's look at this left-hand side. It's the more complicated side. This is the cosine of an angle minus an angle. So that is cosine of A minus B. I'm going to use this formula right here. So I'm going to expand the cosine of a minus b. And this is going to be the cosine of the first thing, that's your a, the x, and the pi is your b. So it's the cosine x times the cosine of pi plus the sine of x times the sine of pi. So let's see if we can answer any of this. I need to find cosine of pi. That's an angle that I can actually find the cosine of, and the sine of pi. And then from our little unit circle here, pi is over here on the negative x-axis. That ordered pair is -1, 0. The first number is the cosine. The second number is the sine. So cosine x times the cosine of pi, which is -1, plus the sine of x times the sine of pi, which is 0, works out to be -1 times cosine, or negative cosine. Let's take a look at how we're doing on our time here. Just got a few minutes left. Awesome, I can do one more example. Alright, back to here, minimize, next page. Let's prove that cosecant of theta minus 90 degrees equals negative secant of theta. Now you're going to see on your formula chart that there is not a cosecant of a minus b formula. However, you can rewrite this as 1 over sine of theta minus 90 degrees, because cosecant is 1 over sine. And then from there we can keep simplifying by the sine of a minus b formula. Let's go take a look at that. Sine of a minus b formula. Where are you? Matchy, matchy, matchy. There you are, right there. There's your sine of a minus b formula. Sine a cosine b minus cosine a sine b. Look at all this is to memorize. You should be thankful that your math teacher is allowing you to use this formula chart, because these are messy, messy formulas. So you just have to play the matchy, matchy game with your formula chart. So it's sine a cosine b minus cosine a sine b. So this would be equal to 1 over the sine of theta times the cosine of 90, got to extend my fraction bar here, minus the cosine of theta times the sine of 90. And let's see what we can answer here. Cosine of 90 degrees, I'm not going to draw my triangle here, but the cosine of 90 degrees is 0. And then the sine of 90 is equal to 1. So this is 1 over negative cosine theta, which is equal to negative secant theta. Boom, shakalaka. So we're still going to be doing proofs. We're still going to be doing some simplification, but we're just doing the bottom part of the formula chart. I will see you guys tomorrow.